The IR6500 High-Energy Rail VACIS System is a non-intrusive inspection system for rail cargo. Its X-rays can penetrate more than a foot of steel, enabling inspectors to quickly determine which rail cars may need physical inspection. HE Rail VACIS can help inspectors answer the following questions. Is the cargo visually consistent with the manifest? Does it adhere to import and export regulations? Are there false walls or ceilings or other secret compartments that could be used to transport drugs, weapons, or other smuggled goods? Are there areas of high density that may be associated with contraband? Are there other irregularities or inconsistencies that may warrant physical inspection? When a rail car enters the VACIS system, several things happen. Sensors and cameras detect and identify the train and measure its speed. Each rail car is scanned with X-rays, creating the image seen on the operator's monitor. The image, along with the rail car's ID number and other information, is stored as a transaction file in the system's database. Each distinct scan of a rail car produces a separate transaction file. Operators view and analyze these images to determine whether a given rail car requires physical inspection. The IR6500 VACIS system requires two operators. The primary operator is responsible for reviewing scanned images, enhancing and analyzing images, verifying that the cargo visually matches the manifest, and making a suspect-non-suspect decision. The roles of the secondary operator can vary by site. Outside the booth, the secondary operator is typically responsible for enforcing safety regulations and communicating with rail personnel. Inside the booth, the secondary operator is responsible for powering up and calibrating the system, conducting scans while monitoring the scanning area, changing the energy level of the X-ray source, responding to warnings and alerts, including emergency stops, powering off the system. The IR6500 VACIS system continuously scans cars in a train. The number of cars that can be scanned is only limited by the space available to store transaction files. The system allows scanning in the speed range of 2 to 10 miles per hour. The optimal speed is typically 5 miles per hour, but denser cargoes may require slower speeds. If the train slows below 0.5 miles per hour, the VACIS system will automatically shut off for safety reasons. The VACIS system can scan rail cars up to 20 feet 2 inches high and 10 feet 8 inches wide. The X-ray source in the IR6500 system can operate at 6.5 or 9.0 mega-electron volts, or MeV. It produces a high-energy beam for high penetration with a very low radiation dose. X-rays are produced by the source, pass through the rail car, and are detected by the detector tower. At 5 miles per hour, the X-ray source can penetrate 10 inches of steel at 6.5 MeV or 12 inches or more at 9.0 MeV. The VACIS system scans rail cars at a 5-degree angle to make it easier to recognize shapes and identify false walls, floors, and ceilings. For maximum safety, the space required to operate the VACIS system is divided into 3 areas. The operational area is the entire physical footprint of the system, the space needed to operate it safely. Inside the operational area is the control area, which is surrounded by cones, warning tape, or other barriers. To maintain radiation exposures below FDA limits, no one is allowed in the controlled area when X-rays are being emitted. When the X-ray source is off, only authorized personnel are permitted in the controlled area. The VACIS system has 3 fixed perimeter cameras to help operators verify that personnel are not in restricted areas when the source is on. The scanning area, or high-definition area, is the area between the X-ray source and the detector tower. No one should cross the scanning area when the system is powered on, even if the source is disabled. The VACIS system has 5 emergency stop, or e-stop buttons that immediately shut down the system when pressed. Their exact locations may vary by site. The VACIS system also has several safety interlocks that will shut off the source or prevent it from turning on in certain conditions. The train approaches at less than 0.5 miles per hour or slows to less than 0.26 miles per hour during the scan. The end of the train passes by the light sensors. An e-stop is pressed or an interlock is activated. Power to the source is interrupted. The controller software closes or the system key is removed. The IR6500 VACIS system has visual and auditory indicators that indicate when the system is on and when the source is powered. The operator is required to test these warning systems at the start of each shift. Once a railcar has been scanned, the image appears on the computer monitor. A variety of image analysis tools are available to help the operator match the features of the scan with the car's manifest to determine whether a physical inspection is warranted. Tools like noise reduction, sharpening, and contrast adjustment can help operators focus on suspect or unclear portions of a scan. Anomalies like dark masses in light areas or breaks in patterns can indicate hidden materials and compartments. Once a scan is complete, the operator can save an annotated image with text and lines to record specific comments about the image and whether the target requires further inspection. VACIS records all transactions in its database where they can be retrieved for further analysis or exported for other uses. The IR6500 VACIS system is a rapid, effective solution for non-intrusive railcar scanning and radiation detection. The images and other information it produces can help operators and inspectors decide how best to examine railcars for optimum safety, efficiency, and effectiveness.